Today we want to really get solid with our knowledge of solving one-step equations. We're going to review the relationship, inverse relationship between addition and subtraction, and realize that we've been solving one-step equations for many, many years. When we take a look at blank or box equals 2 plus 5, you know the answer to this, and you've known this for many years. But now in 6th grade, it's time to be able to solve this algebraically. So as we take a look at blank plus 2 equals 5, we know that the opposite of addition, or the inverse of addition, or what undoes addition, is subtraction. So we can take 5 and subtract 2, and we're going to get 3. So we're already understanding that process. So it's not that much different, it's not different at all, when we replace that box with a variable or a letter that stands for a number. So again, in order to find the answer to the variable, or we call it solve for the variable, we're going to subtract 2 from 5 in order to find 3. And in this case, when we do algebra, we have to make sure that we show the subtraction of 2 on both sides. Plus 2 minus 2 is going to always give us 0. So the variable is the only thing left. A plus, or the box plus 0 would be the box, or A. And on the other side now, we get 5 minus 2, which equals 3. Let's take a look at another example. In this example, we have 4 plus b equals 10. As we start to solve for the variable, or find out what b equals, we really are only looking at the side of the equation that has the variable. For now, we're just ignoring the 10. So we're going to look at 4 plus b, and we see that it's a positive 4. So we also know that the opposite, or the inverse of a positive 4, is a negative 4. So negative 4 is going to be what we need to do on this side of the equation. Positive 4, negative 4 is going to equal 0, leaving us the variable. And that's our goal. We want to know what the variable equals, so we have to get it by itself by doing this mathematical process. But if we've taken 4 from the left side of the equal sign, then we need to take 4 from the right side of the equal sign to keep the equation equivalent. We know that 10 minus 4 equals 6. And as you notice, we keep the equal sign. It doesn't change. It doesn't become a greater than or less than sign. Whatever the sign is there is what we have to keep. So it doesn't matter if you do this process horizontally, like I just did, to try and create an algorithm. You can also do this vertically. So again, I know that the opposite of positive 4 is negative 4. So I would write 4 minus 4 plus b equals 10 minus 4, and I can do it vertically again. And 4 minus 4 cancels each other out, or equals 0. I'm left with a b, positive b, and 10 minus 4 equals 6. So I come up to the same solution, whichever format works best for you. But you have to make sure that you're doing the same operation on both sides. We always check our work. And our check begins by writing down the original equation, 4 plus b equals 10. And now I'm going to substitute the 6 for the b, because that's what I said it equals. And so now I've rewritten my equation, replacing the b with a 6. I can combine 4 plus 6 to make 10. 10 is on the other side. I have a check. Here's one more addition equation that we're going to solve for. It doesn't matter which side of the equal sign the variable is on. If we take a look here, we can see that the variable is on the right. So we're only dealing with the right side of the equation. This is the side that determines if we're going to be using addition or subtraction. So I see a positive 14. I know that the opposite of a positive 14 is a negative 14. So I'm going to write negative 14 or minus 14. I know positive 14 and negative 14 cancel each other out to 0, so I'm left with r, which is my goal. I need to get the variable by itself. But if I've taken 14 from the right side, I must take 14 from the left side. 24 minus 14 leaves me with 10. So r equals 10. And it doesn't, again, this is an equal sign, so both sides are the same. And I know we get used to having the answer always on the left, but sometimes it's on the right. So we have to get used to that. Again, you can do it vertically or horizontally. It's your choice. I'll show both ways here just so that you're familiar. Again, I need to subtract 14. I'm looking at the right to make that determination of what inverse operation I'm going to choose. And then I have to subtract 14 from the 24. So again, positive 14 minus 14 cancel each other out to 0. I'm left with r. And 24 minus 14 equals 10. So you have to use your common sense on how to do the subtraction. I certainly am not going to write 14 minus 24 because 24 is a positive number anyway. And I'm not going to add it. I do need to subtract it. So you got to use your common sense on how you're going to write these mathematical equations. Again, we have to always do our check. Begin by writing down the original equation. 24 equals 14 plus r. We've solved r is 10. So when we rewrite the equation, we're going to substitute 10 where r is. We're going to do the calculations of 14 plus 10 to equal 24. We end up with 24 equals 24, and we've checked. We're going to move into looking at some subtraction equations. But if you need to review anything throughout this video, please rewind and look at it again. And I know that some of you are saying, oh, this is too easy. I don't need to do all of this. Yes, you do. You have to show, you have to prove the math. This is called an algebraic format. It is going to get more complicated. We will get more terms that have to be solved. So please do all the steps and follow the format. You notice that I'm keeping everything very close together except the check off to the side. So please get in the practice of following what I'm doing. So let's take a look at m minus 5 equals 25. As I'm looking at this equation, I'm going to be looking at the side that has the variable. I see m minus 5 or m subtract 5. I can see, I know the opposite of subtraction is addition. So minus 5, the opposite of that is plus 5. And again, minus 5 plus 5 will cancel each other out to 0, which leaves me with m on the left of the equation. Am I done? No, I'm not. Because if I added 5 to the left side, I have to add 5 to the right side in order to keep the equation equivalent. So m is going to equal 30. I really like doing the equation this way because now I have the algorithm right here. I'm not going to forget to add 5. I can see that I've done both of the same operations on each side. So to me, this makes a lot of sense. But again, you have some choice. It's time for the check. It's a simple check, but it has to be done. You have to write m minus 5 equals 25. We write the original equation. We see that we've decided m equals 30, so we're going to substitute 30 into where m is. Now we're going to do the subtraction. So if you have a number, whatever number you've decided m equals, that's the number you're going to substitute, and then you have to do the math. Now this math, it's not just 25 equals 25. It's only 25 equals 25 if your mathematical solution makes it that way. You can't just decide if you had a 40 here minus 5 that it equals 25. Use your common sense, do the proper math, show the format. We'll go through one more subtraction example. 20 equals m minus 40. Again, we're looking at the side of the equation that has the variable. We see that we have a minus 40. The opposite of minus 40 is plus 40. So we're going to add 40 to both sides of the equation. Minus 40 plus 40 equals 0, leaving us with m on the left side of the equation. 40 plus 20 equals 60. So m equals 60. Time for the check. 20 equals m minus 40. You must rewrite this exactly as it is. Now we're going to substitute the 60 in for m. We have 20 equals 60 minus 40 does equal 20, so this is a proper check. You're going to solve for the variable. I want you to pause the tape and get up and get some line paper or block paper so that you can show your work and check. Please number your work. Make sure you put your name on it and the date. I will be collecting these, so make sure they make it to the basket.